The right level of abstraction. It was 2009. I was on the shuttle bus going to work, finally reading Code Complete, after it had already been in my to-do list for a few years. For a couple of months, it became part of my routine, and admittedly, put me back to sleep a few times while reading it under the early morning sun. This was all before anyone saw web developers as programmers. To this day, it is still my Bible for best coding practices, and although it was a difficult read, I knew it was knowledge I had to consume if I wanted to progress in my career. Given the amount of education aid already out there, there's no point in rehearsing here rules and methods you can get from any academic publication on programming. Like I had Code Complete, you might have had your own favorite coding guide. Instead, let's try to analyze the right mindset, focusing on the cornerstone concept of abstraction, which could potentially allow us to apply the established rules and methodologies organically. Why is abstraction so important? With abstractions, we try to encapsulate reusable functionality. By no means is this original thinking. In fact, it has been fundamental for our advancement as a civilization. The whole premise of industrial technology is an application of abstraction. Instead of each household creating its own necessities, we've improved our efficiency by externalizing and streamlining the delivery of goods and services. On the subject of programming, correct abstraction is one of those skills any ambitious coder will have to master. There are so many ways that you can state the same thing with logic, and I always find it interesting reading other people's code. Everyone can code, the same way everyone can dance. Applying the right techniques may transform your code from nonsensical to sheer poetry. And abstraction is right in the heart of the best practices concern, defining how logic is partitioned and allocated. Setting our priorities. The current state of programming entertains diverse opinions on the right level of abstraction. On the one hand, we have miniature formats, many containing one method per component, and on the other, we have frameworks of enormous proportions. Between the two extremes, we have a variety of size and utility any given piece of logic could have. We also see a common phenomenon where an abstraction starts bigger and then gets split up with subsequent enhancements. So what would be the right attitude to tackle this challenge? Since programming is relatively new ground, it's good to seek inspiration from other aspects in our lives, where we have more established practices. If, for example, we take a bookcase and disassemble it, we call those pieces planks of wood. We give them a different name because the purpose of the bookcase is not fulfilled. At what point do the planks of wood form a bookcase? There is a fine line where if we take anything out of a structure, it will cease to be the original object because it can't fulfill the role it is meant to. Conclusion number 1. An abstraction contains everything that is absolutely necessary to define its purpose. Let's take another example from carpentry. One could say that the handle of a door is a separate body from the door itself, and that fitting a handle to every door is an excess expense we can save by introducing a separate abstraction. We simply create a universal handle that fits in a standard handle hole. That way, doors won't need handles. Instead, everyone will have to carry a handle with them and fit it in every door they want to open. This single innovation can save an incredible amount of materials if applied on a global scale. Only thing is, in practice, this will never work. The assumption that everyone will carry their handle is wrong because it's inconvenient, and considering the overall confusion when handles are missing, borrowed or forgotten, this application is mostly ineffective. To add to our previous conclusion, the right abstraction isn't necessarily defined by how small you can partition an item. Conclusion number 2. When in conflict, utility supersedes downsizing. The car is another popular abstraction of the real world. What's interesting with this particular object is that we generally think of the wheels as being decoupled from the car. This is mainly because there are so many different options for wheels. Imagine if we made cars with wheels fixed on them. We would then have to have different car models for every different type of wheels. Even if wheels are a necessary piece of the car, we still see them as a separate entity. Conclusion number 3. Extracting a portion of an abstraction to a separate entity is welcomed when the number of possible customization options exceeds the purpose of the abstraction. Now that we've set the attitude for dealing with this subject, let's see how we can translate it to practical advice on coding. Where do we start? Code shows you the way. I like to think that logic is universal, and that when things don't add up or turn out as we expect them to, it must be for a reason. With that in mind, there are certain conditions we could consider as red flags when judging an abstraction. If you're repeating the same lines of code, if you have come up with peculiar name conventions, if it's difficult to hold on to the right context, if you're going back and forth between the same methods. These are just a few cases where the logic may not be pristine, and you should revisit your primitives. Let's use the conclusion we made before and try to outline the causes of these and similar problems, presented below in order of importance. Scope. You haven't clearly defined the scope of your abstraction, or it is defined in a vague way. Focusing on the characteristic attributes of each object will allow you to more easily define each abstraction. Making Swiss Army knife abstractions is not a good idea. Interface. You have a set of methods you can interact with, but these methods are not adequate and/or ideal. As a rule of thumb, it's better to generalize your approach in creating your interfacing methods so it appears to have the expected behavior. When it comes to exposing features, work in batches. Logic transition. If what you think and what you code are different, maybe you haven't partitioned your logic in the same way you intuitively do to explain the concept. Translating your intuitive impression into code is a sure guide. Readability. Code should make sense when you read it. Whenever your logic diverts too much from the purpose of the method, it is a good idea to consider extracting it to a separate method. Equally, when there's an overlap in the namespaces, maybe it's time to split the logic. Every method in class is a chance for clearing the slate and starting with a fresh set of variables. Size. Simply put, too much bloat. With our attitude adjusted as mentioned above, it is easier to decide what we need to leave in and what to take out. Be merciless and cut everything else. Sometimes limitations are good. If we need to simplify things by not allowing every possible option, so be it. Like any other craft, there are no definite rules in programming to ensure a quality end result. After a certain point, it is up to the subjective taste of the creator to define what is represented and how it is laid on the screen. Given that, the above guidelines may put you in the right mindset so your abstraction layer won't cause you headaches in the long term. It's up to us, being responsible craftspeople, to make sure our work is both functional and appealing.